Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about callbacks in UVM. So before going to discuss about callbacks and UVM, let us try to understand what do you mean by callback in SV. So SystemVerilog doesn't have a function pointers like C. Instead of, we have a callbacks which are implemented using OOP features. So what are these callbacks? These callbacks are nothing but virtual methods or hooks in a base class and derived class that overrides those virtual methods, a main component that calls the hooks and specific times. So what is happening? So in SystemVerilog, when we were discussing about pre-randomize and post-randomize, you have remembered we have two type of functions which is known as pre-randomize and another is known as our post-randomize and another is known as our post-randomize function in SV. When we were discussing, we have told you. Okay, so these two are your built-in classes and these are nothing but our callbacks. So what were happening when we were calling randomize method? When we were calling this randomize method, internally this randomize method was calling this pre-randomize method as well as your post-randomize method. Okay, so if we are declaring the post-randomize method and if you are declaring pre-randomized method and post-randomized method in your code, then only the code which you have written that will be executed, or else nothing will be executed. There will be no body. Okay, so this I have declared without no body. So the user should explicitly declare them and they should declare the body for this. So whenever we are calling this randomized method is going to call the pre-randomized method and the post-randomized method. Here the pre-randomized method and post-randomized method, these are our hooks. So using these hooks, we are going to use these hooks and we are going to develop the body for that, and we are not going to call pre-randomized and post-randomized method. If we are calling the randomized method only, internally it is going to call the pre-randomized and post-randomized methods. So this is nothing but our callbacks. So why do we need callbacks? So basically these callbacks are used for reusing the components without changing their source, add custom functionalities in the test, and make drivers monitors more flexible, allows multiple users to hook into the same event. For example, if we have a driver like this, inside our test bench environment we have a driver, and if we want to add some more functionality into this driver, then without actually going into the driver and changing the code, if the developer have already given a hook for this driver, using this hook we can modify any changes if we want to make in the driver. So using this callback mechanism, we can make the changes from the test itself. We no need to go into the driver and we no need to change any changes. Using this callback hook from the test class itself, we can make the changes inside the driver. Okay, let us see with an example. It will be more clear how we are going to use this callbacks. And plug and play mechanism for reusable mechanism. So in UVM components like driver, monitor, scoreboard, which are written to be generic and reusable, if you had to modify your driver every time you wanted new behavior like logging, delay insertion or error injection, you would lose reusability, because if you always go on and change your driver code, it is not feasible, right? So using this callback mechanism from the test class itself, you can change the properties of your driver. And hook method call mechanism. So callbacks are based on hook method pattern. So a hook is basically a virtual method declared in the callback class. So here we will use this particular term hook. So this is like a so this is your hook. Hook is nothing but a virtual method which is declared in the callback class. So by default, these hook methods are empty, which are going to do nothing. In the randomization also we have seen pre-randomization and post-randomization. Those two are our hooks. Hooks are nothing but they are virtual methods declared just simply as virtual. So the component like driver calls these hooks at a specific point in the execution. So the driver, what it is going to do, it is going to call this particular hooks. So if the user overrides them with a derived callback class, the user defined code runs, or else nothing will be run. So if not, nothing happens since the default hook is empty. So component developer decides whether hook should be called pre-drive or post-drive. So user decides what this hook should do, logging or delay or modify or data. For example, the developer of the driver has given a hook, okay, and the hook is nothing but it's a virtual method. He has just declared that particular virtual method. If you want to if you want to add any body to that, or if you want to make any functionalities to that, you are going to add those particular functionalities and you are going to call them, or else you are going to just simply leave it and nothing will be executed. In this particular example, we have a single driver can behave in many different ways. If we have a single driver, and it should behave in many different ways depending upon the callback register. So each callback adds a flavor or variations of the driver. So this avoids code duplication. You don't need multiple versions of the same driver. For example, if my driver wants to act as a driver plus log callback, behaves as a logging driver just for logging the messages, or if my driver wants to behave as a slow driver, that is, there should be some delay. Initially there will be a driver which has written. Okay, let's say if I want to add this functionalities, like let's say suppose I want to add some delay, and if I want to make this driver a slow driver, okay, or if I want to make this driver as a faulty driver, or if I want to make this driver for logging the messages as well as displaying the messages, or as well as delay driver, or I want to make it as a correct driver as it is. Okay, the three functionalities if I want to add, without actually making any changes or without actually developing another driver code, I can inject the behaviors inside this driver using the callback hook, using this callback mechanism and hooks mechanism. Using this hook, I can make this particular driver without touching the original driver code. So callbacks for injection or delay. So this is also the use case where we are going to use our callbacks. So one powerful use of callbacks is fault injection. So you can corrupt the signals or transactions before sending them. And another common uses is delay injection. You can model slow response times. These are useful for corner case testing and checking for how DUT reacts to faulty or delayed inputs. So this was applications of where we are going to use our callbacks. So the first application what we have seen is our the present readily available application, that is our pre-randomize and post-randomize. So this pre-randomize and post-randomize is the best example to understand this callback. These are our virtual methods which are declared without any body, and if the user wants to use them, they are just simply going to override those methods and they are going to add the body and add their own functionality. We are not going to call this pre-randomize and post-randomize. Whenever the randomize method is called, internally it is going to call the pre-randomize and post-randomize. Now, and one more example which we have seen for this particular callbacks is hook method and callback mechanism, and we have is the one more example is our driver, where we have written a normal driver and this driver is having a hook or a virtual method declared inside that. A driver is having a hook or a virtual method declared inside this, and if I want to make this driver a delay driver, or if I want to make any additional changes inside this driver without actually going into the driver and changing the code inside this driver, using the hook which is available to me as a user from the test class itself, I can insert the changes inside this driver using this callback. Using this callback, I can insert the changes inside the driver. Okay, that is what we are. And if I want to inject any errors inside my driver, like if my driver should behave as a error or error injecting driver, okay, or corrupt driver, then I can make the changes inside my driver using this callback without actually making changes inside my driver, okay, using the callbacks. So this is the applications where we can use our callbacks. Okay, now let us take an example. It will be more clear what I am talking about. First of all, let us try to understand the syntax of our callbacks. If you want to use a callback, first you need to register the callback. Okay, how to register the callback in UVM? We have a macro which is known as tick UVM underscore register underscore CB T comma CB. So this is a UVM macro used inside a component class like a driver or monitor to declare that component supports callbacks. Okay, so we need to register this particular class, register this class. So what is this T? Associates a component type T with a callback type CB. So this T is nothing but our component where the callback is declared, and CB is nothing but the user defined callback class. I will write down here. T is nothing but where the component where the callback is going to be declared, component where callback hook is present, and CB is nothing but callback is nothing but user defined callback. User defined. So we will see about this methods later. First, let us try to understand what is this user defined callback and what is this component hook, callback hook, which is present in the side of the component. Let us try to understand that. So if you don't register this callback pair, UVM will not know that your component supports the callback type, and any attempt to use the callback related functions will issue a warning. So you must register the callback. You must register your class with this callback macro. Okay. And what is this T? So the component or object type that will call the callback, and typically your driver class or monitor class, and must be derived from the UVM object. And CB is nothing but our user defined callback class. Okay, and must be derived from the UVM callback. So let us see an example. Let us see an example for this. So let's say we have a driver. So let's say we have a driver like this, and I want to change the functionality of this driver, or let's say I want to add some more extra functionality to this driver. Okay. So what I can do without actually going into the driver code and modifying the things, what I'm going to do is I'm going to have a callback method declared in this driver. Okay. So I'm going to have a callback method, which is a virtual method, which is declared in this driver. That is nothing but my hook. Okay. Using this hook, I'm going to change, or I'm going to inject any other functionality inside this driver. Okay. How I'm going to insert the functionality? Using this add method, I'm going to insert the functionality. UVM underscore callback hash T comma CB add. So what is the functionality I wanted to add? That callback method I'm going to insert. Okay. Let's see this with an example. If I want to use this callback, uh, if I want to use this callback mechanism, I need to declare a user defined callback class. Okay. The step one is, first of all, we need to declare a user defined callback class. How to declare user defined callback class? Just simply write down the class followed by class name, that is driver underscore CB, which is extending from a parent class which is known as UVM underscore callback. If we want to use this callback property or mechanism, you need to derive a user defined callback class from UVM underscore callback, which is a parent class. And this driver underscore CB is nothing but it's an object. So this UVM callback is also an object class. So we need to register this particular class using tick UVM underscore object underscore utils macro. And here in this class, we are going to declare a virtual task. We are going to declare a virtual task, which is known as, let's say the task name is modify underscore packet. Okay, this is my virtual class which I have declared followed by end task. And if you carefully observe, there is no body which is present here. There is no body which is present here. Just it is simply written. If the user wants to add some body, he needs to derive one more class from this driver underscore CB, and he should override and provide the body for this particular task. Okay, so this is how I'm going to declare. And what is step two? Step two is you need to derive one more class. So you need to derive one more class. Let's say it is class derived underscore CB, which extends from driver underscore CB, driver underscore CB. What is driver underscore CB? This is our class. Okay, driver underscore CB. I'm extending it from it, and it is also an object class. It is also an object class. Okay, so here I am going to override the task which is known as modify underscore packet, modify underscore packet, and I'm going to add the functionality, add whatever the functionality which I need, and followed by end task. So basically I'm declaring the body in this class. Okay, this is also an object class. Now, and here we should be careful that this driver underscore CB and derived underscore CB, so these two are all my objects. Okay, so this should be my object classes. Okay, now what I'm going to do is I'm going to have a driver. I'm going to have a driver class which is present inside my environment and test. Okay, so this is my test and this is my environment, and inside my environment I have my driver. Now from the test itself I can modify the driver without actually opening the driver code and making the modifications. What I can do, I can modify any changes, or I can inject any other extra code inside my driver from the test itself using this callback mechanism. Now if I want to achieve this particular mechanism, first I need to register my user defined. First of all, I need to create a user defined class which is extending from UVM callback, and in that particular class, I need to declare a callback method without any body. Okay. Now, and we need to derive one more class, that is you can say it as derived underscore cp, and there you whatever the modifications you want to make in the driver, that particular modifications you can write it down in this class. Okay. Now what you're basically doing, you can basically add the functionality in this driver using this class. Okay, how to add this? So we have a in the driver class, what we should do is the step 3 we should provide the hook. We should provide the hook. Okay, how to provide the hook? So we can provide the hook by using this method which is known as tick UVM underscore callbacks, tick UVM underscore do underscore callbacks. And what is the component name? Where is this callback hook is present? That is in the driver class. And where is the callback declared? What is the callback name? That is nothing but driver underscore cb. And what is the method which is present as a hook? That is nothing but modify underscore packet. That is nothing but modify underscore packet. This is our hook. Okay. Now this is being declared inside our driver. This is being declared inside our driver. Now inside our test class, and this is declared inside the driver's run phase. This is declared inside the driver run phase. Okay, now inside the test class, I can normally run this driver. Okay, I can normally run this driver. How to run this driver? First of all, create the instance of the environment and call the run method. Everything will be running. Okay, you can run normally, and your normal driver code will be running. Okay, initially your normal driver code will be running. Now, let's say if I want to add some more functionality, or if I want to inject any error, okay, or if I want to inject some other functionality. So that particular functionality I will declare inside this task, which is been declared inside this derived underscore cb, which has been declared from driver underscore cb. That is my callback, user defined callback class. Okay. So this task, using this task, I am going to modify the contents inside my driver. How I am going to modify the contents inside my driver? So in the test class, I am going to use another macro which is known as UVM underscore callback underscore UVM underscore callbacks hash. So first of all, where is this hook present? It is present inside the driver. And what is the callback user defined callback name? That is driver underscore cb, followed by add. I'm going to add this functionality. Where is this driver component present? It is present inside the environment dot driver. And what is the method I want to inject? That is nothing but derived underscore cb. So what happens? The task which is present inside the derived underscore cb will be running. The task which is present inside the derived underscore cb will be running. So this is how we are going to make the modifications inside my driver using this callback mechanisms. Let us try to understand this with an example so that the things will be more clear. First of all, what is the first step? So first of all, let me add the macros here. Tick UVM underscore, sorry, tick include UVM underscore macros dot svh and import UVM underscore. Now I'm going to declare a class which is known as driver underscore cb, which is a callback class which is getting extended from UVM underscore callback. And since it is a object, take UVM underscore object underscore utils driver underscore cb, and function new string name which is equal to driver underscore cb is my name of the class, and followed by super dot new of name followed by end function. Now this is my function new, and here I am going to have a task which is known as virtual task modify underscore packet, and this particular task is a empty task which is not going to have any body, and followed by end class. Now I'm going to declare one more class which is nothing but derived underscore cb, which extends from driver underscore cb, and this is also an object class, UVM underscore object, and it should be an object class only. Utils derived underscore cb. Okay, and so function new string name, which is equal to derived underscore cb super dot new of name end function. And here I am going to have a task modify underscore packet. I am going to override the task which is present inside the driver underscore cb. First of all, let me display tick UVM underscore info get underscore type underscore name inside modify underscore packet method. Let's say we are injecting extra code, or let's say extra packet, followed by UVM underscore and followed by end task. Sorry, and what we are going to do is and followed by end underscore end task. Okay, and here let me declare a variable which is known as which is of enum type. So type def enum, and variables I'm going to have is data underscore 1, data underscore 2, extra underscore data 1, and extra data 2 are my items which I'm going to have in this enum, and followed by packet underscore type. Okay, and packet underscore type, which is nothing but it is equal to packet. So packet is my variable of type enum, and it can have data 1, data 2, extra data 1, extra data 2. Okay, now inside my derived underscore cb, where I'm overriding this modify packet, what I'm going to do is I'm going to randomize it. So how to randomize it? So standard randomize of packet with, let us add the constraint ext underscore data 1 and ext underscore data 2. So our derived underscore cb is adding this particular constraints, that is this packet can contain this ext underscore data 1 and ext underscore data 2 is my constraint which I've added, and followed by end class. Now, so let us write down the code for our driver class. Driver extends from UVM underscore driver. Let me register it UVM underscore component underscore utils, and let's say it is we are extending it from UVM component. And so function new string name, which is equal to driver UVM component parent super dot new of name comma parent end function. And I'm going to have a phase which is known as run phase, task run underscore phase, UVM underscore phase. And inside this task, what I'm going to do is, first of all, I'm going to create a hook which is nothing but tick UVM underscore do underscore callbacks. This is how I'm going to create a hook so that any derived class can use this hook, and UVM underscore callback. And what is the, where is this hook present? It is present inside this driver. And what is the callback type? It is nothing but driver underscore cb. It is nothing but driver underscore cb, and followed by what is the method name? It is modify underscore packet. It is nothing but modify underscore packet, and followed by what I'm going to do is I'm going to call the drive task. So first I will call the drive task before this hook which we are providing. After that I'm going to provide the hook followed by end task. So this is my hook, and followed by now I'm going to declare a task which is known as drive task. This drive task is going to, what it is going to do is, first of all let us display UVM underscore info get underscore full underscore inside driver class method UVM underscore loop. Now here what I'm going to do is I am going to use the standard randomize of packet with what is the constraint which I'm going to provide is packet is equal to data underscore 1. So basically I'm going to have this packet of type data underscore 1. Okay, data underscore 1 and followed by end class, end task and end class. Now let me declare the environment which extends from UVM underscore environment. Let me register it UVM underscore component underscore utils environment. Let me register it function new string name is equal to environment and UVM component parent super dot new of name comma parent and followed by end function. And in the build phase function void build underscore phase UVM underscore phase super dot build underscore phase of phase. And here I'm going to declare my driver class driver drvh, create the instance of my driver drvh which is equal to driver type id create drvh end function and followed by end class. Let me declare the class which is known as test. So let's say it is base underscore test which is extending from UVM underscore test, and let me register it UVM underscore component underscore utils test, that is base underscore test function new string name which is equal to base underscore test UVM component parent and super dot new of name comma parent end function. And inside my test build phase I'm going to create the instance of my environment function void build phase UVM underscore phase. What I'm going to do is super dot build underscore phase. First of all, let me declare the environment instance environment envh, and let me create the environment instance here envh is equal to environment type id create of envh comma this end function. Okay, and inside my top module followed by end class, and let me declare a top module. Let me call within an initial beginning block run underscore test base underscore test end module. Let me save this. First of all, let me declare the language UVM 1.2 and tools and simulators on deck. Save this. So we are getting inside driver class method. This is so we are getting if we are running this test, we are getting inside driver class method. Okay. So let me add one more test case here. So let me create one more test class test underscore 2 which extends from my base underscore test, and let me register this test underscore 2. Okay, and function new name which is equal to test underscore 2 and UVM component parent super dot new of name comma parent end function. And in this let me add the build phase also function void build underscore phase UVM underscore phase, and let me declare the derived class derived underscore cb, that is this one. So let me declare this class handle also, that is nothing but this class handle. I'm going to declare derived underscore cb. Okay, inside my test underscore derived underscore cb dcb. So I'm going to create the instance of that dcb, which is equal to derived underscore cb type id create, and it's an object. Okay, so it will have only one argument. Now after creating this, what I'm going to do in the build phase, let me add the super.build underscore phase, and in the build phase, I'm going to, after creating the instance, I'm going to use a macro which is known as, I'm going to use a function which is known as UVM underscore callback is my class. And what is the parameters I should provide? The component which the hook is present, and the type of the callback, that is driver underscore cb. I'm going to access a method which is known as add. So this add is a static method which is present in the UVM callbacks. Okay, so I'm going to access that method. Using this method, what I'm going to do, the first argument of this method is where the, I should provide the path where the driver is present. So the path is envh dot drvh is the path, and I want to replace this driver. I want to utilize this hook which is present inside my driver. I want to modify it with the method which is present inside my derived underscore cp. That is nothing but I'm going to write down the dc. Okay, this is what I've written, and followed by end function and end class. So this is my test underscore 2. Okay, so let me run this test underscore 2. So we can see here. So let me register this derived underscore cb class with the factory. Yes, we can see here inside the driver class method that is being called, and we can see here inside modify underscore packet injecting extra packet. Injecting extra packet. We are not actually modifying anything in the driver. We are not at all modifying anything in the driver. So using this callback only from the test class itself, using the hook which is present inside my driver, I'm injecting extra method inside my driver. So this is how I'm using my callbacks for adding extra functionalities to my component, which is nothing but my driver. Okay. And if I want to delete this callback, I can use the static method which is known as delete. So here I've written add, right? So I can use delete so that the callback will be deleted. I will show you where should we write. So in the test class, in the test underscore 2, we should use delete method so that our callback will be deleted. Okay. So this is how we are going to use this callback mechanism, and we are going to develop our code. So that's all about this particular video. If you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this.